Go for it.
What way do you want me to do?
I don't care.
Do sum and difference, you know.
Sum and difference. I love that you said that. Write that down, people. Sum and difference. How'd you know sum and difference?
Because I saw a negative equation and a positive.
Yeah, but it has more than just that.
Yeah, I mean the signs.
Everything else matches. Do you see that? So we have 7k squared plus 3 and 7k squared minus 3. Okay, keep going, David.
I did 7k times 7k. It'll give me 49k to the 4th.
Gave you 49k to the 4th.
And then I did positive 3 times negative 3.
Very good. Guys, give it up for David. All right, so today, guys, we are starting 7.4, our last lesson before our exam, solving polynomial equations in factored form. So before we were only dealing with expressions, right? Expressions don't have something that equations do have. What do equations have? Write that above there, okay? So we are now going to be dealing with the equal sign, all right? Now, before I jump into this lesson, I would like to take questions from last night's homework. So let's jump back to that for a second. See how easy the first part of the lesson is. Okay, so the first thing I want to point out is something called factored form, okay? Factored form is like before you distribute. Do you guys agree if you looked at this, you would immediately be like, okay, I want to distribute this x to both terms? Yeah. And you would end up with what we call standard form, right? You distribute x, you get x squared plus 2x. You guys cool with that? We are going to be leaving it in this form, which is called factored form, okay? The reason we're leaving it in factored form is because we want to use something called the zero product property, okay? Now, you probably have never heard of that property before. It's very, very easy and probably one of the most used properties in all of mathematics. Now, let me explain how the zero product property works. Over here on the right, find some space. I need you to write down two sets of equations. I need you to write down 3x equals 0. And I need you to write down x plus 1 and x minus 1 equals 0. Okay, so let's start with the one on the left. 3x equals 0. Now, I don't want you to imagine this as like, oh, this is an equation, you just divide 3 by both sides. I want you to think of it logically. This is saying 3 times some number x should be equal to 0. Do you guys agree with that? What is the only number that when you multiply it by 3, it gives you 0? Christian? 0. So the only value for x that works here is what? 0. Now, that is true for 0. 0 can only happen when one of your two factors are 0. You guys agree with that? So if we're looking at this second equation, which is x plus 1 times x minus 1 equals 0, we need either x plus 1 to be 0 or x minus 1 to be 0, correct? So what would make x plus 1 0 if x was negative 1? Because what's negative 1 plus 1? 0. Now, what value of x here would make x minus 1 0? If x was 1. So essentially what we're doing, what the zero product property says, and it's really cool, is that if two things are multiplied by each other and set equal to 0, you can set each of them equal to 0. So we got x minus 1 by saying x plus 1 equals 0. And we got x equals positive 1 by saying x minus 1 equals 0. You're just setting each of your factors equal to 0. It is the most useful property you will probably learn about in a very long time. And this extends all the way to calculus. You continue to use the zero product property all the way in calculus. Any questions so far? Okay, so what we call these answers, once we get them, is we usually called them a solution. Do you guys agree? We'd be like x equals 1 and x equals negative 1 are our solutions. Now we're going to use another word. It's called our roots, okay? These are called our roots. And it's essentially the same thing as a solution, okay? All right, so let's jump down and let's go ahead and apply that property to these equations and let's solve them. So initially, right, you would look at this and you'd be like, oh, I really want to distribute the 2x, right? Yeah. But I said leave it in what form?
Factored form.
Factored form. This guy's already in factored form, so leave him the way that he is. If these two are being multiplied, 2x times x minus 4, do you guys agree that's multiplication right here? Yeah. If they're being multiplied and together they equal 0, each one of them needs to be 0, agreed? Yes. So we're going to set up two equations. The first one's going to be 2x equals 0, and the second one is going to be x minus 4 equals 0. And sometimes it helps, guys, to literally underline your two factors. So I have 2x and x minus 4. I'm going to set each of them respectively equal to 0 and solve for x. So in 2x equals 0, what do I get?
0.
X must be equal to 0. And in x minus 4 equals 0, how do you solve that for x? You add 4 to both sides, and you get x equals 4. Who's been paying attention? What do I call these two values? These are the roots. Very good. How many roots did I get? 2. How many factors did I have? 2, right? I had 2x, and it was multiplied by x minus 4. Any questions on the first example? Ooh, sorry. Does it kind of make sense, guys? Okay, let's try another one. Whoa, go ahead.
So is that just the answer?
Yeah, those are the answers. That was it. X equals 0 and x equals 4.
Oh.
Okay, let's try this one. X minus 3 times x minus 9. What do you think I do?
X equals...
Okay, which ones?
X minus 3 equals 0.
X minus 3 equals 0 and
X minus 9 equals...
x minus 9 equals 0. Easy, right? Solve it. What do you get? X equals 3 and x equals 9. That is it. Easy peasy lemon squeezy. There's a catch. No, it's that simple. That's why, guys, the zero product property, if you can get it to factored form, it's so useful, okay? And you're going to see how freaking important this is because we're going to use this the rest of our year. Yeah, what's up?
Would it ever be where we have it
In standard form?
and we have to turn it to factored form?
We will eventually, okay? All right, so check out C. What would I do in C? X equals 0 and x minus 1 equals 0. Guys, do I have to solve the first one? No, it's already solved for us, so just circle it. How do I solve the second one? Add 1 to both sides, so x is actually equal to 1. That's it. And each of these solutions, I also call them what? What's another name for them? Roots. Okay, you have to get very comfortable with that word. All right? Let's try D. Now, it's very common for people to say that t equals 3. That is incorrect. What do I set up, guys? 3t equals 0. And when you divide 0 by 3, what do you get? T equals 0. The second one, how do I set it up?
We do x plus 2.
T plus 2 equals 0. So t is eventually going to be negative 2 because you subtract 2 from both sides. How are we doing? Are we okay? You're not ready for the next part? You'll be fine. You'll be fine. You got to have a good confidence though, okay? You have to have confidence. All right. So I want you to think about this. If the product of two factors is 0, will there always be two roots?
Yes. No.
Maybe so.
Yes.
The answer is no. I want you to think about when would we only have one root if there were two factors?
They equal 0.
If they both equal 0? Okay, if they both equal 0, then we'd only have one root, which is x equals 0. Do you guys agree? But what if they were both 2? X equals 2.
Well, I still want to.
We would still only have one root.
I mean, one root.
which would be x equals 2, but it happens twice. Does that make sense?
Yes.
So check this out. I want you to write down an example. What if we had x plus 2 and x plus 2 equals 0? How would I solve this?
You would just do the same thing.
I would do the same thing. X plus 2 equals 0, and x plus 2 equals 0. What do I get?
You would get -2.
X equals -2. So I only got one answer. Do you guys agree? But it happened twice. So I have one root, but I had two factors. This is something that's called a repeated root, and we'll talk about it a little bit later, okay? So I want you to put no, comma, you can get the same root. Root for both factors. It is funny once you guys... Okay, the answer's on the board. You should have gotten z equals 4, z equals 6, x equals -2/3, and x equals 4. Talk about it in groups. See if you made a mistake. Go. All right. Bring it back in. Guys, can someone walk me through E? How'd you do E? Caitlin Alonzo. Z minus 4 equals 0. And then z minus 6 equals 0. So z equals 4.
6 minus 6 is 0, so z equals 6.
Z equals 6. Very good. All right, F. McCarvin? Wait. What do you... Oh, set it up first for me. Set it up first.
3x plus 2.
3x plus 2 equals 0. And x minus 4 equals 0. Very good.
So for the first one, I subtracted 2 from both sides.
Mm-hmm.
Then I got 3x equals -2. I divided both sides by +3. And I got x equals -2/3.
Very good.
And for the other one, I added 4 to both sides and I got x equals +4.
Very good. How many of us got all 4 of them before I went over them? Let's go. Okay. Peeps. I said a repeated root is when what happens? They're the same number. Please circle that, okay? So if you get the same number for both solutions, okay, it's something called a repeated root.
Mr. Jurko, can I borrow your charger?
Okay, let's check it out. So let's try this first one. We have 2x plus 7 times 2x minus 7 equals 0. Sophia R., what would you do for this one?
My first equation would be 2x plus 7 equals 0. And then my second one would be 2x minus 7 equals 0.
Okay.
And then add minus 7 from the first one.
Yep.
And then I did 2x equals 7 divided by 2. And I did x equals 7/2.
Close. Segi, what happened?
She forgot the negative on the...
Very good. Okay, a simple mistake, but makes a big difference, okay? Hey, but nice job on the rest of it. Someone walk me through the second one. AJ. Add 7. Okay, what do I get? Mm-hmm. Mm-hmm. All right, guys. Are these repeated roots? No, why not? They're actually different. One's a positive and one's a negative. So these are not repeated roots. We still have how many roots here? 2 roots. Okay? They're 2 separate roots. We only get one repeated root if they're the exact same number. Same sign, same number, same everything. Okay? Check out letter B.
Oh, wait a minute. What do we do?
I know this.
Wait a minute.
Oh, I know what we do.
What do you do, David?
We set up x minus 1 parentheses, and then do it again.
Ah, why?
And then, because it's the 2, and then you do x minus 1 equals 0. And then you do it again.
Ah. So now we would add 1 to both sides. We get x equals 1. and we would get x equals 1. Mia, you said this is what?
Repeated root.
This is what?
Repeated root.
Very good. These are repeated roots. Repeated roots. So how many solutions do I actually have? One. But how many times did it happen? Twice. Okay? So this is an example of a repeated root. Addison, you good?
Can I go to the back?
Yes, you may. Yeah.
When it's a repeated root, you just write repeated roots.
Correct. Now, if you were to write your answer, if you wrote x equals 1 twice, okay, I wouldn't take points off, but technically there's only one answer and it's x equals 1. Okay, so you could just write it once and you'd be fine. Yeah, McCarvin.
If we see a problem like that, can we just like, do we have to show our work? Because we already know it's going to be the same answer if it's squared. So can we
I'm
just
scared about this
repeat
lesson.
No, you could write, if this asked you, if a question like this appeared, you could literally just write, I know it's going to be x equals 1. That's the only thing that would make it work, okay? Now, sometimes it asks you how many times, what's the duplicity of that answer? How many times did this root repeat? The only way you know that is by actually solving it. How many times did we get x equals 1? Twice, okay? It'll also match that exponent up there, okay? Does that make sense? Okay, good question. All right, guys, I want you to try C and D on your own. So C,
Oh, I know what
it
is.
looks intimidating,
X to the third. I mean, 3 to the third.
but there's going to be 3 roots. Why is there going to be 3 roots in C? There's 3 factors, okay? So try C and D, go. Okay, talk, share, compare, go. Talk about it. Okay. Are we good on these? Any questions? Mateo, what's up? Are you just stretching? There's no questions? I can move on? Okay. All right. This is where, yep. Hey, all of you that just sighed, take a look at the back of the classroom. What do you think I'm going to ask of you right now? Have a growth mindset, okay? Listen up. That growth mindset is so important because you just moaning or like complaining or sighing, right? That is already, you're like, I can't do this. This is too hard for me. But if you change your mindset and you're like, hey, I haven't even learned anything yet. Maybe this is really easy for me, right? You have no idea. You have to give yourself a chance. Bet on yourself that you can figure this out. Are we clear? Yeah. All right, let's do it. So this is factoring polynomials using something called the GCF. Who remembers what GCF stands for?
Greatest common factor.
Write it down, people. Greatest common
I forget this.
factor.
I was never gonna have to go
Factor.
back to this again.
Okay. The greatest, keyword greatest common factor, okay? Let's go over what those 3 words mean. Greatest means that it's the largest thing that you can pick, correct? Common, what does common mean?
Like they're similar, they the same goal.
It's like the same. Very good. It's shared between the 2 of them. And what's a factor? Factor. Multiplication, okay? So we're thinking about things that are multiplied, that are in common, and it's the biggest, okay? So check it out. We're going to do a visual for the first example, and I color-coded it so you can see what's happening. What you're looking at is you're looking at 4x to the 4th and 24x to the 3rd. Think about the greatest common factor. Start with the numbers. What is the greatest common factor between 4 and 24? 4. So look, in purple, we have 2 4s. Do you guys agree? You are dividing both terms by that 4. Guys, what's 4 divided by 4?
1.
So you're not going to have a number inside because you don't need to write a 1. Do you guys agree? So inside my parentheses, what's technically there that we don't see it? A 1. If it helps you to write it out, write it down. What is 24 divided by 4? 6. So what's inside my parentheses? A 6. Hold on. Questions at the end. Now, x to the 4th is like x times x times x times x. Do you guys agree? And x to the 3rd is like x times x times x. Now, I want to know what's the largest amount of x's they have in common. There's 3 of them. Why is there not 4?
Because that one is not with the other.
The other one, it only has 3. Do you guys see that? So, Guess how many x's we pull out on the outside? X to the third. That's where the x to the third term comes from. Now, this is where some people make mistakes. Take x to the fourth, divide it by x to the third. In other words, subtract the exponents. What's 4 minus 3? So we have 1x left over. Do you guys agree? Now over here, we have x to the third divided by x to the third. What's 3 minus 3? So how many x's do I have left?
0.
None. They're all gone. So we only have the 6.
This makes so much sense now. This is easy.
Hold on. So when we write it as our final answer, we write the greatest common factor, which was 4x to the third outside, and whatever's left over on the inside. So x plus 6.
How do you jump from that, which is good? Like, I understood that, but then you just get that answer.
Now watch. Hold on.
Yeah,
I promise you, I will take questions after example B, because I want to show you from start to finish where you don't see all these steps, and you're going to be like, I see it now. I get it. I got it. I'm Gucci. Okay? If you got it, if it clicks, what do I expect from you? Help the people around you. Okay? Because maybe it didn't click for them yet. All right. Hey, people. So A, just put, that's the one on the side. Just draw a little arrow. That's the one on the side. Okay? We just did that one together. B, as I said, start with the numbers. So underline 8 and 24. What is the greatest common factor? It's 8. They're both divisible by 8. Do you guys agree? So watch. We're going to put 8 on the outside. We're going to put parentheses. And then we're going to take it one step at a time. Guys, what is 8 divided by 8? 1. So there's a 1 on the inside for the first term.
Why are you dividing it?
Hold on. What is 24 divided by 8? So do you guys agree that there's still 3 left over on the inside? Okay. Hold on. Change the color you're writing with, please. It makes much more sense if you change the color. Underline y squared and y. Guys, how many y's do they have in common? 1. So we're going to pull that y out and write it on the outside. Now, check this out. Y squared divided by y is basically 2 minus 1, right? You have 2 y's, you're taking away one of them. How many are left over?
1. Wait, where did you get that?
I don't understand.
No,
Hold on.
It's really easy because I just got.
This is y divided by y. How many y's are going to be on the other one? None. Because it's factored out.
First, what did you get this first one? Where did you get that one?
Well, this one was y squared, so it's y times y, right?
Yeah.
Take away one of the y's, how many do you have left over? 1.
But why did you take it away?
Because it's factored out.
It's just too many steps.
Okay. Hey, people, let's write it the correct way. It's going to be 8y on the outside and just y minus 3 on the inside. Okay, now let me show you why this is important. You're going to draw an arrow. You're going to label this your check. Okay? And you're going to write it again. 8y times y minus 3. Just by eyeballing this, what would you guys think to do if I were to show you this and be like, get it into standard form? Distribute the 8y. Okay, so distribute it. What's 8y times y?
8y to the power of 2.
And what is 8y times negative 3?
This is beautiful.
Do you guys notice something?
Same thing.
It's the same thing that we started with. So, people, before you ask me a question, I want you to make that connection. This is the opposite of distribution. Factoring and distribution are the same, just opposites of each other, like multiplication and division, right? When we factor, we're pulling a term out. When we distribute, we're multiplying that term in. Go ahead, McCarvin. Alfonso, you can go after him. Caitlin. The negative 24? Hey, hold on. I have a good question. How did this negative 24 turn into just 3? We divided it by 8y. What's 24 divided by 8? 3, right? And then we take y. We're dividing out a y, so you have nothing left over. So it's just the 3.
Another one because I don't get it.
We're going to do more examples, okay?
Oh, me?
All right, check it out. Letter C. Hey, we're too much right now. Let's bring it back down, okay? I need you guys to focus because I can guarantee you there's some people in here that it's not clicking for them yet, and they will not get it if you guys keep distracting them, okay? All right, what do I always start with?
The numbers.
The numbers. What's the common factor between those two? 4. No, there's a higher one than 2. 4. Pull out a 4. Let's start with the 4. What's left over? 8 divided by 4? 2. 4 divided by 4?
1.
Okay. Then I move on to the
Exponents.
exponents. Well, it was a minus because there's a minus here, okay? Keep that same sign. Guys, how many x's do they have in common? 1. So pull out only one of the x's. You had 2 x's here, x squared. Do you guys agree?
Yes.
You're factoring out 1. How many are left over? 1. The second term only had 1 x. If you factor it out, what's going to be left over?
0.
No x's. So don't write anything. You guys cool with that? Okay.
Wait, I don't get it.
Why do we have a second? Oh, no, I'm sorry.
You're good?
Don't you have
Are you
one
sure?
Y? Don't you have one Y?
We're not on y's yet.
Oh.
Yep.
You said there's 0, but we still put it in.
What do you
Wait,
mean?
why don't you put an
You
X
said
on
you
the
don't do
board?
anything with that one because it turns into 0. But
It doesn't turn into 0. It turns into 1. X divided by x is 1, not 0.
How did you get the X next to the 4? And the X next to the 2?
Okay. Then we move on to y to the third and y to the second. How many y's are in common?
2.
2. So factor them out. What am I going to factor out? Y squared. What's 3 minus 2? Still 1 y left over. What's 2 minus 2?
Oh, you're going really fast.
There's no more y's. Your final answer is 4xy squared
Can you do one by ourselves?
times 2xy minus 1.
Can you do the X and the Y again?
So for y's, it's y squared and y cubed, right? There's 3 y's here, y times y times y, and y times y over here. How many y's do they have in common? 2. So we're pulling out y squared. Do you agree?
Yes.
Now, subtract the exponents. 3 minus 2 gives you 1 y left over, correct?
Oh.
Now, 2 minus 2, how many y's are left over?
0.
None, so you're just going to leave that 1, okay? Another example. Another example. This is how we get better. This is how we get better. All right, what do I always start with? Okay. What's the common factor? 3 is divisible by 2? 3. What's 3 divided by 3? What's 12 divided by 3? 4. What's 6 divided by 3?
2.
Oh my gosh, there's another one.
That went so fast.
Then go with the x's. Guys, this has x squared, this has x. Does my last term have an x?
No.
So can I pull out x? No. So we're going to leave it as x squared. We're going to leave it as x, and the last term does not have x. You can't factor anything out there.
Why can't you do
Because remember, it's greatest common factor, so all of them have to have it in common. Do we agree? Now, what about y? Do they all have y's? What? Which one doesn't have a y? So can you factor anything out? No. So you're just going to leave it as y and y squared for the last term. This is your final answer.
This is so fun. No, I don't get it. I get it. I get it. Okay, no, this one was easy, but the last
Shaggy?
one wasn't easy.
No, why do they all have
Now, if they all had a y, you could factor out a y.
Okay, can we do one? Wait, we do one by ourselves?
Okay, hey, hey.
Would the 1x squared just be written as x squared?
Yeah, you could just write as x squared. No, absolutely not. Okay. Hey. I'm going to write 2 more examples because you guys have asked me to try some on your own, and I want you to try them on your own, okay? So we're going to do 3x squared plus 9x factor it, and then also factor, we're going to do, second one is going to be a little bit more challenging. We're going to do 8y squared x plus, nope, we'll do minus. And then we'll do 12yx squared.
I already did it. I didn't even have to do it.
Shh. Guys, don't give it away. It's very important that the person next to you makes their own mistake so that they can learn from it. The first one, you should have gotten 3x times x plus 3. Guys, I need you to make sure that everyone got it in your group. Talk about it, go.
You see how the first one?
5, 4, 3, 2, and 1. Does anyone think they got the second one?
No.
Natalie?
I got 4yx times 2y minus 3x.
Guys, give it up for Natalie. That is correct.
Bro, what?
Yes,
So I got that, but then I changed the 4yx to 4xy.
that's fine. Okay. Did you guys hear what Addison did? She wrote it as xy instead of yx. That's fine. Okay, the order of those does not matter. Okay? Yeah.
Why is the X in the center? It's not in the first.
Well, remember, so AJ, this one only had one x to start with, right? You pull out an x. Is there an x left over in that first term? No. Yes, Caitlin.
I don't get where you got, like I get the y, but I don't get where you got the 2y.
The 2y. Well, what's 8 divided by 4? Think about when you factor out, you're dividing by that factor, okay?
Can you walk us through that question?
Okay. What's the greatest common factor between 8 and 12?
4.
Factor it out. What's 8 divided by 4?
2.
What's 12 divided by 4? 3. So you guys understand where the 2 and the 3 come from? Okay, moving on. How many y's do they have in common between the two factors? 1. So factor out a y. We had y squared. Take out a y. How many y's are left? You still have a y. Only one y though.
Wait, but see, how do you have 2 y's then?
It's 2 times y. There's only one y there. The exponent's 1 now, Mia.
Okay.
Exponents are different than coefficients.
Okay.
Okay. Then the second one, we had x squared and x. How many x's are in common? 1. The x here is gone now because there's only 1 to start with. Do you guys agree? Take out an x from here, there's only 1 x left.
Okay, I get it better now.
Okay, moving on. Guys, now we have to solve some equations by factoring. We're going to do 2 examples and then we're donezo. Okay? So, you have to, this is the zero product property, but in order to use it, it can't be in standard form. So we have to do what? Factor it. So, take a look at the numbers, 2 and 8. What is their common factor? 2. Guys, it's not 4. Does 4 go into 2?
No.
4 is not a factor of 2. 2 is a factor of 4. Do you guys see the difference? But 4 is not a factor of 2. So we pull out a 2. What are my numerical portions left? A 1 and a plus 4. How many x's do they have in common, guys? They have 1 x in common. So pull out 1 x. You started with 2 x's. You take away 1. How many are left? Just x. And the second one? It's just 4.
I actually did it. Oh my god.
Well, we had 1 x, right, Kaylin? You factored out one of the x's. Wouldn't there be no x's left? This one's x squared, so there's 2 of them. It's x times x. Think about it like this, Caitlin. You see how there's only 1 here? If you bring it to the outside, it's now gone. You can almost like scribble it out. So there's 1 x with this term. There's no x's with the second term. Correct. No, take out 1 from both. It's a common factor, so it has to be in common. Okay? Now, this is set equal to 0, correct? So set it equal to 0. 2x equals 0, and x plus 4 equals 0, correct? What's the first one going to be equal to?
0.
And the second one?
-4.
All right, for B, guys, I'm just going to show you how to do it, okay? It's not equal to 0. So in order to use the zero product property, you have to make it equal to 0. You should subtract 15n from both sides to start. You're going to get 6n squared minus 15n equals 0. And then factor and solve, okay? We're going to stop here, turn in your notes, and then start packing up. You subtracted, Mia, because you have to set it equal to 0 in order to use the zero product property.